Like I said when I introduced you to imaginary numbers, there's another application, and that's dealing with complex numbers. Uh, Within the imaginary numbers video, I actually kind of gave you a little bit of an intro when we added with our imaginary numbers. A complex number is in the form of a plus or minus, depending on what we're talking about, bi. So in the imaginary numbers video, I showed you an example where we took the a plus bi and added a plus bi. So you guys already have an intro to this. The next step is when you actually need to multiply, and this is where it can get tricky. So for instance, if I were to have 3 plus 2i times 6 minus 4i. So I distribute this just like I normally would with any other multiplication like this. So 3 times 6 gives me 18. 3 times negative 4 gives me negative 12. I got the I there, so it hangs out. Then I've got 2i times 6 gives me 12i, and 2i times negative 4i gives me negative 8i squared. So now I go through and I combine my like terms just like I normally would. The 12i plus 12i actually cancels out. But the funny thing with this I squared, remember, is that the I squared goes to a negative 1. So I really have 18 plus 8, which gives me that 26. So even though it's back there as a negative 1, make sure that you know that it's a 8 times negative 1 to give you a plus 8. A lot of people, they'll do 18 minus 8 and then subtract 1. They forget that that's really multiplication there because they see the negative. So that's just something to be cautious about. The next thing that we're going to deal with is what we call a complex conjugate. A complex conjugate is where when you multiply them, you're going to eliminate this middle term of that 12i, whatever your middle term is. And the reason why is because then you get rid of the I and then it's going to become a real number. So a complex conjugate, if I have a plus bi, the complex conjugate is a minus bi. And the reason why you want this is because if we have a fraction of some sort, our imaginary number can't be in the denominator. So what that means is that we're going to simplify this by multiplying everything by the complex conjugate. So for instance, if I were to have 2 plus I divided by 3 minus I. So like I just said, you can't have imaginary numbers in the denominator. You can have them in the numerator, but not in the denominator. So in order to get rid of them, I'm going to multiply by the complex conjugate. So 3 plus I. And I'm telling you now, this is going to eliminate the I in the denominator. So you need to go through and do distribution for the top, and then do distribution for the bottom. So for the top, we're going to do that in red. I've got 2 times 3, which gives me 6. 2 times I gives me 2i. I times 3 gives me 3i. And I times I gives me I squared. Now I'm going to do this to the denominator. Got 3 times 3 gives me 9. 3 times positive I gives me plus 3i. Negative I times 3 gives me negative 3i. And negative I times positive I gives me a minus I squared. So now I can go ahead and combine my like terms for the numerator and the denominator. So in the numerator, I've got 6 plus 5i plus negative 1 there. Because remember, I squared goes to negative 1. In the denominator, I've got 9 minus negative 1. So I'm just going to simplify this a little bit further. I've got negative 6, or positive 6 minus 1 gives me 5, plus 5i, divided by 10. Now, notice all 3 of these numbers can be reduced. If all 3 of them can be reduced, then go for it. If it's just one, or if it's just 2 numbers, then it doesn't actually reduce, because that 10 goes to both the 5 and the 5i. So 5 over 10, that means I got 1 plus 1i divided by 2. Okay, so you need to reduce if possible. So that's how we multiply by complex conjugates. Again, the goal is to get rid of the middle term where you have an I in order to simplify your denominator.